So this week we are going to start section views, and I want to jump right into what we're going to take a look at. And there are multiple ways of drawing section views, and I'm going to share my. Where'd it go? So I'm just sharing my my screen with you. Actually, I'm sharing you my document camera with you. And so here we have this object. So at first look of this object, there's not a whole lot that we can take from the object. Other than that, there are 4 holes and a slotted hole that runs through the middle. So if we were trying to describe something or give dimensions for someone to make this part, it would be pretty difficult. We could tell them how big it is, how tall it is, you know, how long, how wide, how tall, the fact that there's 4 holes and a slotted hole in the middle, but then we would be missing a great majority of the drawing itself. Because then we would have to take this object and then we would draw that as a isometric view. And as we go to our isometric view, we could see that, oh, hey, there's some things going on here. And this is not actually a line, but a center line here. And that center line represents the center of those circles. So now as we're looking at those, we're going, that really looks different. And I'm not sure what I'm looking at. So I'm going to share something else with you. You're looking at my SolidWorks, right?
Yep.
Okay, Dan, I'm counting on you for the head nod. But if I look at my part and I spin my part around, I can find out that, wow, there's more things going on with this part, that it's hollowed out on the inside, and that there's a slot on the inside of that. So going back to my camera, as we look at this, now we can start to put together that isometric drawing that, okay, we have our height, we have our length, we know that this makes more sense now that there is another recess in the bottom, and that this is an empty hole here in the bottom. But can I dimension any of this? I can't give any of this information to anybody because I can never dimension to a hidden line. So what I have to do is I have to be able to turn this drawing into a section view where I can see the inside of the drawing. Now there's a couple of things that we have to keep in mind when we're talking about section views. The first thing we have to do is we have to identify what is it that we want to see. Okay, so I'm going to start with, I would like to see what's going on between these holes right here. So in order to identify a surface, I have to have a cutting plane line. Maybe that's not dark enough. And with my cutting plane line, it is a phantom line because it doesn't really exist. It's just showing the person looking at the drawing, where am I actually cutting through. So this is a little heavier line. And remember, in our AutoCAD files, we loaded up a phantom line. So all I did was change that to a phantom. So that is telling me that I am going to cut. So if you had an old cheese cutter, with a little wire on it, that would be an example of what am I going to cut through. It's cutting through the entire thing, cutting it in half. Now, that's one, and I'm going to call this BB. And I'm going to put a letter by every arrow. And every section view always has two letters. We always start out with AA, BB, CC, DD, and so on. We stay away from I and O because those can look like other, an O can look like a 0, an I can look like a 1. So we try to stay away from those. But if I get all the way through ZZ, then I can come back with AB, AC, AD, and so on. Now, I've never seen that many used, but it definitely is possible. So again, just to repeat, we have a phantom line, and this is going to be our cutting plane line. And our cutting plane line, just checking my notes here, our cutting plane line is going to determine what we're cutting through. And it tells us, the arrow direction tells us which way we are going to be looking. So in this case with BB, when I cut it in half, I am looking from right to left, looking at that edge. Now I would want to see another view cutting right to the center. And this would actually be my first view, and I would call this one AA. Now, having those section views, we're taking one view and we're going to create a view where we can see the inside, where we can create dimensions. Now, in the case of the drawing we're looking at right now, I'm going to turn the front view and the right side view into cross sections. And I'm going to replace the front view because really the front view, the only thing I can get out of this drawing right now is my height and my length. The only two pieces of information that I can give, because all these hidden lines I can't do anything with. Okay, so by turning those into section views or section drawings, it allows me to give some more information. So moving into my CAD file, I'm going to set our front view. Now these are not to scale. I just quickly sketched up this view here in SolidWorks, just have a 3D model real quick. But I think they kind of give the same point. So again, I still have my cutting plane line, AA, and I'm going to replace the front view because really what I'm doing is I'm just going to cut that half off. So when I cut it and then I flip it up, then I get to take a look at it. So if I were to take this case right here and I were to cut it in half, then I would flip it up in this direction, and this is what I see. If my arrows are pointing that way, then that's the direction I'm going to follow the arrows. That's what I'm going to see. That makes sense? So as I look at my drawing here, so I have section AA. Section AA says I'm going to cut the drawing in half, and I'm going to look this way, which is the same thing as replacing my front view. So now in my front view, over here, I had some hidden lines. I'm like, I'm not sure what's going on. Now, we know what's going on. And we could take a look at this line here and say, well, wait a minute. What does this line right here, I know why it's hidden in the whole view, but why in this view is it shown when this comes up? Okay, and I've got a simple example for you on that. Go ahead, what's that? Rosa, do you have a question?
Oh, no, sorry.
That's okay. All right, so if I had something that looked like this, we'll call it a magnet. What would that look like in the front view? So if this is the top view here, what would that look like in the front view down here?
Block with some hidden lines.
Well, not hidden lines, because that would come down, right? Isn't that what it would look like in the front view?
Yeah.
Because I'm seeing this edge right here. This edge is this edge. This edge is this edge, right?
Yep.
This right here is showing me that right there. Would you agree with that?
Yep.
Right? So this line right here is really showing me that surface up there. So when we take a look at the downside of our, or the opposite of our section view, even though there's no material here in the middle, and I'm going to stop sharing my camera and do something a little different here so I can swap back and forth. So if I'm looking at my object here, when I have this line right here, what I'm really seeing is this surface over here. Does that make sense to everyone? So let's bring this guy over here. Oops, come on. Where'd you go? I lost it. Oh, it's stuck on my mouse. I can't get it to move. Let's just stop and do this, see if it lets me move it. That's crazy. It wouldn't let me move it, but it will in a second. Here we go. There we go. Now we got something I can show you. So as we look at the two, and I'll zoom this out a little bit, and that's what we'll do here. Slide you down. Visualizer, there we go. So now as we're looking at the hidden line that we see right here, which is this hidden line, if we look at the 3D model, this line right here is really representing that surface, that whole surface that's blue. It's not representing the hole, it represents that entire surface. So this hidden line right here represents the blue surface that you see in the SolidWorks. And just to clarify, you guys are seeing both my camera and the SolidWorks, correct?
Yes.
Okay.
Yeah.
So when I go to the section view, what section views do is they remove hidden lines. So the difference between my orthographic projection view with hidden lines, and now I have my my section view. So as you look at that section view, you could say, well, wait a minute, where did the holes go? There was a hole that was right here. Well, but when I take the section views remove all holes, or all hidden lines. So when I cut this object in half, cutting on line AA, this hole over here, I can't see anymore because it's behind material. So now I have my 45-degree lines. These represent material. So I always give the example of that's like a butter knife. When you cut through a stick of butter with a butter knife, you get those little groove lines. So this represents material. Now, yes, there is a hole in the back, but remember, we're removing hidden lines so that we can show clarity. On the other side, those hidden lines are also removed because what I'm focusing on is the slotted hole that's in the center so I can see it here. Now, I could put dimensions on this drawing and I could come through and say, hey, here is the dimension. I'm just going to call it 1. Dimension 2. in dimension 3, and now I can put all 3 dimensions because I can dimension to something I can see, whereas in my other view, I can't see it, so I can't dimension to it. Now, I can't dimension to a hidden slotted hole. I can call it out, but here I can dimension. I could do a continuous dimension. To here, I have another dimension that I could bring down. And I didn't space that out very well when I did that. But I can put a dimension. So here's 1, 2, 3, 4 dimensions that I could put in there. And of course, I'd want to space those out and give myself some room. But now I have some room to show what it is that I want to show. So, and then I'm also going to always label my sections, section AA, section BB. I don't want to not label them because then someone can look at this and say, well, what is this a drawing of? But when they see, hey, that is a section, AA, they can go and find the cutting plane line. There it is, section AA. Oh, I'm cutting that block in half. That's what it looks like on the inside. In this case, I'm able to create section BB with my right side view. Again, I'm eliminating the center hole because there's solid material between there. So as I look at it and say, oh, here are the holes that I would see. I'm still cutting through the little hole in the middle, the cavity in the middle. So I'm going to see that, and I'm going to see the 2 holes that dead end into it. So now I can get some more information. So how wide is this? So now I can put that dimension on there. I don't necessarily need my height dimension because I can see it, but now I know that these holes go through and stop into the cavity itself. I would still do my holes. I'm still going to dimension those where I see them in their true size and shape. And in this case, I'm going to treat my cutting plane lines like they don't exist. I don't have to worry about them at all. Now, obviously, I'm not going to put a dimension right down through it. I'm going to have to come out here a little bit and go around it, so that I have some information. But I'm not going to have to worry about that. It's just part of the drawing that we're not going to worry about. Does that make sense?
Yeah.
All right. So this type of section is called a full section. So in a full section is when we go all the way through the part. And I'm going to put in a straight line. So a full section, go ahead.
Are there partial sections on?
Yes, there are other types of sections. We're going to talk about those just in just a second. So the first type of section is a full section. Okay, so a full section, we're going to cut the whole piece in half. So even though I'm cutting just an edge of it, but I am cutting all the way from one side to the other, full section, the whole thing. Not that I'm cutting it exactly where it needs to be, but I'm cutting the full thing. Now, our next type of section is called an offset section. And an offset section is designed when I want to see multiple items. So I'm going to have the same block again here. And I'm going to have some holes. And I want to see what it looks like through all of those holes. So my offset section is going to be offset. And then when I draw my offset section, I'm going to find out that I had a countersunk hole, a through hole, and a counterbore hole. Where when I was looking at the front view, I couldn't really see that but when I did a cross section, I could see it. Now, this also, if I had the same thing and I had another line that went like this, it could highly have been possible, likely, that I had something that looked like this. And I wouldn't know what it looks like until I cut it in half to see those edges. Does that make sense? Why we do an offset section? Now, in this week's, this is day number 2 of week 12. And there's a PowerPoint in here that you're going to want to take a look at.
There is only a day 1.
There will be, and there's another one in just a second. Now there's a day 2, and it says cross sections. If you refresh you'll see it. I just opened it up.
Yes, thank you.
So there's a PowerPoint in there, and it seems, if I remember correctly, there's about 40, 50 slides. So there's some really good information that you're going to want to get through there. So there's not only just full sections and offset sections, but we also have half sections. And a half section is when we are going to take half of an object. And half sections are reserved for round features. So when we take a half section, notice that my cutting plane line only has one arrow. And that's because we can't look in 2 directions on a round object. I can't look forward and down. Okay, I've got to be able to look one way. So I am looking only in one direction. So as I look at that, here's my round object. Here's my hole. I'm not going to show anything on the bottom. This actually represents the center. This is the center line. And I'm not even going to show the bottom because I'm only going to show this section, this piece here. Okay? So I'm just showing the material. Now where this could play in, if I were to add another section to this, this might look something like this. And we would only see that in the section view where we're cutting in half so we could see the hole. Okay? We'll cover a little bit more of this. So that is our half section. We also have what we call our revolve section. In our revolve section, is used when I have circles or items that are on a circle, but they don't necessarily line up. So in this case, I would take my cutting plane line and I would draw 2 arrows on it. And then when I drew it, it would look just like a full section. It would look flat. Because what I am saying is and this would be, for an example, like a wheel puller. If it spins really fast, all of a sudden the holes always look like they're lined up. So we're saying it's revolved, meaning that they are the same center. So we're just showing that is the same. You might show this on kind of pipe fitting, like a bolt, a flanged elbow. where you're going to say that it's all the same, even though they're not equally, they're not, you know, vertical. They may be staggered on an angle here, so we're coming down, but we know that they share the same circle. Does that make sense to everyone? Okay. The last section that we're going to talk about is called a broken out section. And a broken out section is one we're going to use, and the example I've always used is a rake. So I could fit a rake handle, but in relationship, my handle is going to go clear off my page. So I'm going to have my handle and now I can say that this is 20 feet long because my handle never changed its size. I just took out a section or removed section, broken out or removed section. So I'm just removing part of it so that I can look. In some cases, we'll put in a circle showing us what it looks like when it's revolved at that section. Okay, so in review, we have our full section, our half section, our revolved section, our broken out or removed section, and then we have our offset section. The two most common types, or the three most common types of sections you're going to see are going to be your full section, like we have here, your offset section, where we're trying to see multiple features, and then your half section, where we're trying to see objects. Okay, so we'll use those and we'll interject those throughout. Now, I want to show you in AutoCAD how I did the same drawing. So here is that same drawing that I drew in AutoCAD, and I drew it just like I did any other isometric drawing, starting the left or the top view, projecting to the front view using my miter line. I just erased it. But people often ask me, how do you get the arrowheads? That's really simple. I just go up here to a dimension, and I click, like there's my dimension. And then I go to the home, and this little box right here, this is explode. So I'm going to explode it. And when I do, I'm just going to get rid of those two lines. And there are my arrows. Okay, and that's exactly what I did with these. So if I want to rotate it 90 degrees, now it's pointing up. Then I use my text from that dimension. If I was creating another section, and there's my C. So I just use a quick dimension to get my arrowheads and then to create my letters. Now, when I was drawing with AutoCAD every day, I created some blocks, but this is the easiest way. In a blocks, I would create this little arrow and I would save it as a block, but I don't want to confuse you. If you know how to use blocks and you're using it, great, continue to do that. But just creating a simple dimension is the easiest way to get those arrows. If you want your arrows a little bit bigger, SC for scale. Make them a little bigger if you want them bigger. These are up to you to how that you want those to look. That seem easy enough so far? Mm-hmm. All right. So now there's the hatch. Okay, and this is new. So the hatch, this is the material, and I'm just going to delete my hatching. So this is the material. So I want to know that this is, what's hidden. So I took my hidden lines and turned my hidden lines into object lines. Then I went up here to hatch. Now, before I did that, just had to move my window, the block for Zoom. I'm going to go to layer hatch. So I'm on the proper layer. Then I'm going to go over to hatch. Now the way that hatch works, there are lots of different types of hatch patterns. And back in the day, in the 80s, we had to memorize these, and we had tests where we had to actually draw them when they would say, okay, what's the hatch pattern for brick? What's the hatch pattern for steel, for brass? And we had to memorize those. I have long since forgotten what those are. But these ANSI standards will tell us which each material is. So we're just using a simple ANSI 131, which is common steel. So I'm selecting on that common steel. I know that it's going to be on bilayer. I know that it's going to be at the scale of 1, and it's rotated at 0 degrees, which is fine. When I move my mouse into it, it's going to find the spot that says, hey, that's a closed loop. Once I select, and I'm going to select the other side because that's the same, I'm going to hit enter. The reason I do that is because when I delete, those two are 1. So if I went back to hatch again and pick this guy and hit enter again, it goes back into the same thing. Now they are each their own entity, and I want to make sure that I have them together. Okay, so common mistake. People go like this and go, oh, hey, I've got to hatch this. I got to hatch this guy. I got to hatch the pattern there, pattern there, pattern there. And they go, good, I got to go. And then they try to move it. They go, what just happened? But because they were all done at once, that's the problem. So I'm going to delete all of them. If I do it again, now if I go hatch and hatch, enter. When I hit enter, notice it brings back my hatch ribbon again. Now this is one, and this is one. So now when I go to move, it moves just fine, and it's not affecting anything else. So you want to make sure that you get those. Now, let's say that I have multiple materials. Let's just say, for the sake of you using the hatch tool, that there are different materials in here. So I could go with hatch and say, you know what, I need to switch materials. And I'm going to come here and say, well, that looks kind of like the same. So what I'm going to do is I'm going to rotate that, and I'm going to rotate that 30 degrees. Now when I put that in there, notice that they're going different directions. So I would probably do that, actually not 30, I'd probably change that one to 40. Let's see, 45. How about 90? There we go, 90 would be better. So now it's going at a different angle, so now we could say, well, hey, that's something different going at a different angle. So this would represent one type of material, this would represent another type of material. Now, we know that we can't have one there because that's actually a hole. But if I was doing an assembly, let's say, of a turntable, where I had, or a die, where I had the die shoe, and then I had a stripping plate that was on top of that, and then I had another piece of the die steel on top of that, they would be different materials. I would just change the way that those orientate. I don't ever have them all going the same way, because if I hatch this and go back to our original, now it looks like it's all one material when really it's not. So if I were to change that to 90, ooh. We could say, hey, there's something different going on here because there's this material. See how I can make the difference between those two? Okay. So that's cross-sectioning. I want to get into different types of holes that we're going to be covering. And this is important knowledge that you need to have. And there are different types of holes. So there is just a typical twist drill hole. And all of these are notes that you can get right off from day 12. I just opened up this PDF. The twist drill hole, notice at the bottom of the twist drill hole, we see the relief. This is usually at a 30 degrees or 82 degrees. So that's showing the cutting surfaces. So when I use a twist drill and I don't go all the way through, I'm showing the cutting edge of the twist drill. So when I see that in a cross section and go, oh, that was a drilled hole, I can tell by the way that it looks. There's a boring hole. In a boring hole, it does twice the diameter, so it actually is going to spin. So as it spins, it's going to get twice of the diameter. Does that make sense? So it's got this little cutting edge feature. We don't see this a whole lot, but that's going to be a straight through hole. Notice that the lines here, what are they representing? Not the hole, but the material. Oops, you guys are over here. Material behind the hole. So that's what we're looking at. We've got the reamer and a machine reamer. They're the same thing. Just one's used by hand and it doesn't spin as fast. But a reamer has lots of flutes. That's what these little lines are called here, the flutes. Versus a twist drill that typically has two, the flute has many. So when the twist drill spins, it gets the material hot. And when the material gets hot, it expands. Okay, when it cools off, it shrinks. So we can't get a very accurate hole. So if we want a 1/2 inch diameter hole, we drill a 1/2 inch hole. And when it cools off, it shrinks farther. Then we take a 1/2 inch reamer and we go about doing and ream that hole out. And then we get a machine hole that we can actually truss. Now there's a counter bore and a spot facing tool. Notice they look pretty much the same. You can use them interchangeably. So typically with a counter bore tool, you're going to drill the hole first, using a regular hole, and then this is going to match the size of the hole so it centers the larger hole on top of it. The difference between a counter bore and a spot face is a spot face the distance that it's going to cut. So remember that a counter bore, the whole purpose behind a counter bore is to put, for example, a socket head cap screw. You really can't put a square-headed nut on the outside. You can't get a wrench on it. So a socket head cap screw, which is like a screw that has an Allen head on the inside, can now sit and be recessed all the way underneath the steel so that it can't be touched by anything above it. Now, a spot face is used typically when there's an angled surface. And we might not be able to even see that angled surface, but that spot face is going to come down and it's just going to make sure that it's level. So when the head of the bolt comes down and touches off, it is touching solid and not on an angle. So for the spot face, I'm drawing mine very, not a good drawing. I have an edge. Here's my material. I'm going to put a bolt in that guy. So if I'm going to try and put a bolt in there, notice that my bolt is only going to hit on one spot. If I take and put a spot face in there, and there's my spot face, now when I put that bolt in there, that bolt will sit flush and have a perfect contact on it so that it sits flat so it doesn't weaken the bolt. So that's where we're going to use a spot face. So again, our counter bore and a socket head cap screw, you may have seen them. Looks something like that. And on the edge, outside edge, they look kind of like that. So it's like an Allen wrench that you put on the inside. So with those, this is where that countersink is going to come in play so that we can attach different materials without interfering the head of the bolt. Now we also have our countersink. Okay, and our countersink, for example, if we're using drywall screws are the one thing most people recognize, and we want that screw head to hit flush. Notice that there's this line right here in the back. So when I have my screw that's coming down, this line right here represents, here's, I'm trying to see if I can get my paper to do it. When it rotates, my edge of my paper inside here still has an edge, does it not? The Rosa, you're looking diffused, Tommy.
I don't know what you're doing with the paper.
Just a second, let me put my bag of tricks over here. So there's my screw. So you can see the bevel on my screw. Can you see that?
Mm-hmm. Yeah.
There's the bevel on the screw. That's what we're trying to countersink. Well, that is like a cone that goes all the way around. So that is an edge. So it's going to change. So when I draw that countersink, you can't tell right now if I'm starting to draw the screw or the back side of the hole, and I'm drawing the back side of the hole because that back side of the hole is rounded, kind of like a bowl. Okay, so this is where that rounding stops, and now it just goes to a straight through hole. Okay, so that's what, and so many times I have students that do this, and they go, "There's my countersunk hole." I'm like, well, where's this line right here that represents that back edge? They do the same thing with a countersunk hole. They do this. I'm like, well, where's that back edge? It's still there. Remember the horseshoe example we used? That whole circle, if you look from the top, you've got this whole edge right back here that represents right there. That's what we're trying to show. Does that make sense to everyone? Okay, hopefully this is the one area that really gives a lot of people a lot of difficulties, and I'm not sure why. And then there's our tap. And a tap drill is a way that we create threads. You'll need to know this for the test. Okay, this is important to know because when we start talking about drilling a hole, now Rosa, I'm gonna call you out here for a second. Rosa asked me, should drilled holes be in diameter or radius? And we never talked about it. But if you go to a drill set and say, hey, I need a 1/2-inch radius drill, you're never gonna find it, right? Because a 1/2-inch radius drill is gonna give you a 1-inch hole, right? So holes are always labeled in diameters. How big are they? Fillets and rounds are always in radiuses. So just a way to remember that is if it's round equals diameter. If it's not complete, that equals radius. And on my drawings, the drawings that I give you, I will interchange those intentionally, trying to confuse you, to get you to say, okay, well hey, I will say on this that this is a 1/4-inch radius circle. You know, 1/4-inch radius, getting you to think, oh, that's a 1/2 inch. So we are intentionally trying to trick you. We're trying to get you to think, oh, that's a hole. That's, just to see where you're going to think. And they've done this in drafting since the invention of the classroom, I think. So just keep in mind. Now, typically, you're never going to see on here that that's a 1-inch diameter fillet. Fillets are almost always done in radiuses, but we'll intermix. So just remember, when you're dimensioning, holes, full rounds are in diameter, partial rounds are in radiuses. Okay? Your first drawing that you're going to be working on oh, I'm sorry, I got to go back one more. So we got one more bit of lecture tonight before we really get going. I told you there was a lot of material we were coming tonight. And that is threads. And we got to cover this because it's going to be on the final exam. So when we're looking at threads, I already have this. So I already have this on Blackboard so you can see it, but I want to talk our way through it here a moment. So when we take a look at threads, there's going to be a thread call out, and I use a common okay, and this note is going to tell me everything that I need to know about the thread. So the quarter, this equals the diameter. How big around is the diameter? So if I have a 1/4 inch bolt, the 1/4 inch bolt isn't going to be any bigger. When I cut threads on it, the threads are actually going to go smaller. The 20 is equal to the pitch, or threads per inch. And what that means is if I measured 1 inch, if I took out my scale here and said, okay, here's 1 inch. Between here and here, there would be 20 ribs on the screw. So looking at my screw here, so if I look at this screw right here, I could say this one is 1, 2, 3, 4, 5, 6, 7, 8. So this one only has 8 threads, but the pitch on the screw is only 8. That makes sense? Whereas I looked at this screw has much more on an inch. So that 20, we're counting each one of those threads, and how many would I count? So on a 1/4 20 and a 1/4 20-inch bolt, I would count 20 ridges of the thread. That makes sense to everyone? The UNC equals the thread type. Now, UNC actually stands for Unified National Coarse Thread. And there's also UNF, which stands for Unified National Fine Thread. So I know that there is a 1/4 28 UNF 2A. So that 1/4 would be the diameter. The 28 is the thread per inch. So the difference would be an example of, hey, these screws are the same size. This one's got 28 and this one has 20. Now, that's not the correct count for these, but this is the best example I had sitting here in my desk. So I know that they're the same size, but the number of threads. So one's a fine thread. So the UNF tells me that's the thread type. Now, there are lots of thread types out there. There's square threads, Acme threads, American Standard threads, but this is part of the only thing you need to know that is the thread form, what type of thread it is. And then the 2A, the 2 is the class of fit. And if you go to the hardware store, everything you're going to find in the hardware store is going to be a class 2. Class 1 and class 3 become a little more loose, a general, and so class 2 is a general, class 3 is going to be a super tight tolerance thread that's going to be a little more specific. But most bolts you're going to see are going to be 2. Now, the A or B. Now, this only comes from me. That I made this up for myself so that I could remember. An A is an external. EXERN. An external thread. HRE. And I know that this is a bolt because it is an A, and A equals around. B equals an internal thread. And B equals bottom. And where I came up with that, so if you go to the bottom of a glass, you're on the inside, right? Not on the outside. So if you're going around something, you're going around the outside. And if you go to the bottom, you're on the inside. So at the bottom of a hole, you're on the inside of that hole. So B means an internal thread. So B's are for nuts. And A are for bolts. So I will guarantee that on the final exam, you are going to see something that looks just like this, and it's going to ask you, what does the quarter stand for? You can just tell me that's the major diameter. The major diameter is the biggest it's going to be. 20 is the pitch. How many threads per inch? The UNC or UNF, depending on which one you're given, is the thread type. And then the final one, the 2A, class of fit, internal or external thread. Now, there are many, 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 many more parts to the thread. As you can see on my notes here. So I have the minor diameter, and the minor diameter is at the bottom, what we call the root of the thread. The top of the thread was what we call the crest. Okay, so the angle of the thread is always determined by the thread type. This is a lot of information that I don't expect you to know. We'll cover this again in VR 180. We cover it again in EG 221 or 201. We cover this in many places. The pitch diameter is halfway between the crest and the root. So typically, when we talk about the class of fit, we're going to talk about how close is that pitch diameter going to come to interfering. Because if they're touching that bolt, that nut's not going to spin on there very well, right? So this is how we take a look between the two. Now, there's also, as we are looking at we talk about our holes, there are some notes that we need to know. And they are right here, and I'm glad they're on my board here. So when I want to write a note that says that I have a counter bore, I don't have to have a symbol. I can type in C bore, which equals counter bore. And then I have that little symbol, that little U. And that symbol U equals the counter bore symbol. So both are interchangeable. And then we have the countersink, the CSK, which is our countersink. Or it looks like a V. It's like, oh, hey, that's a countersink. And then we have the little anchor guy, which tells us deep. So we know that we're going in a depth. And I'm going to show you an example of how we would use that. So I have a hole. So I'm calling out I've got this hole. So I'm going to call this out. I'm going to use a leader. And on my leader, I'm going to put that I have a 1/2 inch counterbore by 3/8 deep with a 1/4 inch diameter hole going all the way. And I don't put anything. So I'm like, oh, hey, wait a minute. The 1/2 inch counterbore, so that's the outside. It's going 3/8 deep, so I know how deep it's going to go. So if I'm looking at it from the side, there's my 3/8, and then the 1/4 inch is here. And I know that that 1/4 inch is going so deep. If I want that 1/4 inch hole to go to a depth, then I would add in, I put a comma and say, let's say 1/2 inch deep. So then there would have to be a bottom to that hole. Any questions on any of that so far? All right, so I can only see a few of you. So if you don't, you may have to pipe up or pop in a message to me.
Always makes complete sense when you explain it.
What's that?
I said it always makes complete sense when you explain it, when we're doing it here together.
But now you have a video to go back and look at too.
That's true.
Oh, yeah, someone's got a question. Jacob, your internet is shaky. I've got it recorded. So let's take a look at the drawing that we're going to do, one of the drawings that we're going to do for tonight. And this is the trip finger. Okay, so we're going to draw 3 views of the trip finger. And we're missing a drawing. I'm missing my holes drawing. I gotta find it here. We'll talk about this right now though. We're gonna have the trip finger drawing, 3 views, a full section. So if we draw a full section, where are we gonna cut this thing? Yeah, right down the middle, right down the middle. So we are going to cut it right down the center, right down the center line that we can see right here. So we're gonna cut that thing in half. It's gonna be at full scale. So we're gonna wanna see what it looks like. So what we're gonna do is 3 views. We are going to replace one view. So we'll replace the front view with a section view. Okay, does everybody understand what I mean by that? So
Yes.
all of the lines that would have been hidden are not hidden because they're all gonna be visible. So we'll have a front view that's gonna be a cross section. Still gonna be labeled. In the top view, we'll draw the top view, which we see here. We'll have to put in our, see if I can do this. Oh. New tool I just found. So we're gonna have our section view, right? We're gonna call that AA. And this will be of the top view. So we're gonna have the front view. is looking at that view, and our right side will be looking at that direction. Because our top is looking straight down from the top. That seem good? Okay, so that's going to be our drawing here. If you hold on a second, I'm looking for the other drawing that seems to be missing.
You don't need it.
Oh, it's kind of an important one. Just wondering if I moved it to next week. Well, which should be this week, because we should be in week 13. And it is. And in our other drawing that we have for this week, is our holes drawing. So we're going to be drawing this drawing. So we're going to be drawing this drawing in two views. We're going to be drawing a top view, and that top view is going to be about a full drawing, not drawn as a section view. Right now it's shown as a full section. So we're also going to show a full section in the front view, but in the top view, we're going to show the other half of this guy. So that top view it's hard to draw with my mouse. Oh, that's terrible.
Just going to be a block with a bunch of circles, right?
Yeah, this is terrible. This can't do anything here. That thing doesn't have a shapes. I'm trying hard here. Looks like I've had a few. There we go. Yeah, so we're going to have, hopefully your holes will line up, but we're going to see the front view, and then we're over here, we're going to have our holes. And it's going to correspond to what we have going on down here. So hopefully your drawing looks a lot better than mine. Just a couple of things that I want to point out is make sure that you remember, here's that line that I'm referring to. Here you can see that sloped edge better. We're seeing that we're going away from a sloped edge in our countersunk hole. We're seeing that back edge. So the line that comes across represents this back edge. Our countersunk hole is the same thing. So this is a spot-faced hole. This is a countersunk hole. Notice they're no different. Okay? The difference is the depth. So we have a 3/8 diameter hole going all the way through, followed by a 3/4 inch hole that's an 1/8 inch down, so that's a spot face. A 3/8 diameter through, counterboard with a 3/4 inch, depth of a 1/4 inch coming down. Here we have a 3/8 diameter hole going all the way through with a countersunk at 82 degrees. Now people often say, how do I do that? It's real simple. Draw a line and then rotate a line, or draw a line from that point going up, rotate it. So this is, let me undo. Take the center. It's important to have the center of the hole, okay? So we know that the outside diameter is going to be 3/4, so here's my 3/8 hole. Here's my 1/4 inch hole. So here's the top of my block. From this point right here, make that guy at 41 degrees. 41 degrees, and just mirror it around the center, so you'll get the other half coming up here for a total of 82 degrees. And then our last one, we have a 15 16ths by 18 NC. What's NC stand for? Take a stab at that one.
National course.
National course 2B. There's B, internal. Okay. And then they're telling us that this is a number or 0.257 F tap drill. Okay. Now you can see that there are hidden lines within the cross section. That's because those are not hidden lines. That is a simplified version of showing how threads are going to be shown. So there are multiple ways that we show threads. That's just a simplified, so we're not drawing all of the little zigzag threads going through there. So here are all the dimensions you need. So you know if it's 3/4 to the center, we know it's 1.5 inches. From top to bottom is 1.5 inches. We know the thickness of from top to bottom is 1 inch, so all that information is there. Now, how do we get those notes in there? The last thing that we're going to talk about before I cut you guys loose or really get back to any questions. So I'm going to go back to my AutoCAD here. We'll stop this, go to AutoCAD. Wow. And I have to remind myself every time, how do I do this? So what I have to do is I have to go to my my G Drive or my Google Drive, and I actually have it saved in my G Drive as far as these codes and how to make this work. So I'm bringing those guys up because I never remember them. And I call it GD&T, which we're not going to get into this year. We won't have time with everything that we've had going on. Here to go. There it is. So this is just a little thing that I popped and I saved offline. So the way that we get the depth is going to be a small x is equal to the depth symbol. Small v is going to give us our counter bore. And the w, our countersink. I don't know why it picks those ones, but that's what it is. Has everybody got those? Okay. Again, it's going to hear in the video if you need to get back to it. So when we're in a drawing, so this works in single line text, not so much multi-line text. But if I go into multi-line text, I'll show it you here first. There are some objects that you can input. I'm looking for them. I'm not seeing them. They're here somewhere, but I don't do it this way. I'm going to do single line text. Enter, enter. I'm just agreeing with all those. So I want a diameter. So I didn't give you this one either. Percent D gives you diameter. So I'm going to say percent D. Oh, that's degree. It's C. I'm sorry. Percent C gives me the diameter. Percent diameter. So I go diameter 3/8. And now I want to have Wait a minute. I got to show you a couple different things. So percent C is going to give you diameter. Percent D is a degree, and percent U is underline. So if I go percent U, everything I type is going to be underlined. Okay. Now, if I go back to multi-line text, I have to change my font, and I've got to change that to GDT. And once I go to GDT font, now I can type in percent C, there's my diameter, 3/8. Now I want the depth, so I know that's going to be small x. So I believe it should be percent x, which is given me with x. So 3/8 with a counter bore is going to be V. So there's counter bore. 3/8 inch counter bore of a 1/2 inch. X for deep by 1/4 inch. So I was doing the same thing, percent C, C for 3/8, 3/8 whole. And this one's going to be countersunk. So countersunk is going to be W, small w, countersunk. 82 to countersunk of 3/4. Percent C, because I got to get the diameter. 3/4. Percent D to get me degrees. Okay. Now we don't use these this often. In SolidWorks, the symbols are given to you. You can just insert those symbols. I believe that if you go to the symbol library here, you can also get some of those. So you have to search for them, but you can find them in here too. So we'd have to go to GDT. There they are. So here it is. So now I can insert those same ones and say, okay, I want to go with, where's my depth? These are GDT symbols. Oh, there's my depth. And I could use these in, when I close this out. When I'm in my other text, I can insert those. If I'm in single line text. Maybe not. I'll play around with that and get back to you on that one. But those are the 4 that you're going to need to know. The biggest thing is remembering you have to go to GDT font to find them. Now, remember, you don't need those. We could just do it this way and say I'm percent C, 3/8 C bore, 1/2 inch, deep. So we could type it out in using words too. You don't have to use the symbols. So whichever you feel most comfortable with, fine with me. I don't really care. Okay. Remember when we're drawing the drawing, where are you? Got to find it. Got too many drawings up here. Remember when we're drawing this, we're going to try and keep all of the notes on the top view, above the top view, and the dimensions for the center of the holes, those are going to go between the views, in the front view and the top view. So for next week, you've got the full section of the holes drawing. We have the full section of the holes drawing. Next week, we're going to do an offset section and some other sections where I'm going to give you partial drawings where you're going to draw, you're going to finish them. And then we're going to be into our final exam. Just know that your final exam is going to require a full section. Now, that's the one that we really need to focus on, is the full section for our final exam. There will be some things on GD&T on there as well. You're just going to skip it on the final exam, and I'm just going to give you the points because we won't have time to cover all the GD&T. Okay?
So that drawing that you just had up, that one's not until next week?
No, the trip finger, the one that I just showed you, the trip finger and the holes drawing, we'll draw those this week for next week.
All right.
Next week, I've got some drawings that I'm going to give you. They're partially drawn. I'm going to give you CAD files, kind of like what we did with the auxiliary, the tutorial 1 and 2 for auxiliaries. I'm going to give you a partially drawn section view for an offset section, where you're going to have to finish the drawing for me. So you won't be creating everything. You'll just be trying to finish off what I've already added. Okay? And then we'll cover that. We'll talk a little bit about our final exam. And then your final exam, we got to talk about how we want to handle that. I'm thinking what I'm going to do is I'm going to time it. It's going to be a 2-hour time limit, and you can take it whenever you want. So that when you open it, you'll have 2 hours to open it, get the instructions, read it, and submit it. That's kind of where I'm going with that one. Okay? All right. Hey, it's been a longer one tonight. I'm just looking at how long we've been on. So it's full hour and a half. It's going to be a long upload on this one. So, all right, you guys have been wonderful. You don't have any other questions. That's all I have for tonight, all right? All right, let's get to it. Stay safe. We'll talk to you next week again.
Yep.
Thanks.